In this video, we'll go through the main key points from each distribution. We'll start off with a Poisson, which we know it's a discrete distribution, and its PMF is equal to the following: x factorial. The mean of a Poisson distribution is equal to lambda, and its variance is also equal to lambda. The second one is the exponential distribution. Here it's PDF. Remember, you use PMF for discrete and PDF for continuous. The PDF function is lambda e minus 6. Is mean is 1 over lambda, and its variance, same thing but squared. This is for the exponential distribution. For the binomial distribution, which is the discrete distribution, the PMF, it's nx, p to the x, 1 minus p, and x. Its mean, because n can be greater than 1, is np. So n, it's the number of trials, p is the probability of success, and its variance, it's np, 1 minus p. A Bernoulli distribution, because n equals 1, this is the main difference. It's the same distribution, but it's a specific case where n equals 1. So the probability mass function is exactly the same, but because we have n equals 1, so in the end expression, the result will be a little bit different. So everything else here is the same, p of x, 1 minus p n minus x. But now here, our expected value, so our mean, is equal to p, because n equals to 1. And our variance, same thing, but because n equals to 1, now we are left off with p, 1 minus p. This is for the Bernoulli distribution. For our negative binomial, our PMF, as we've seen, is x minus 1, n minus 1, p to the x, 1 minus p, and minus x. Our expected value is x over p, and our variance is equal to x, 1 minus p, over p squared. The specific case we have with a negative binomial where n equals 1, this is the case that we have the geometric distribution. So again, it's still a discrete distribution, but now we have a situation where n equals 1. So you use the same expression because it's easier to memorize. Px 1 minus p n minus x. But now, because this one equals to 1, combinations having this one equals 1, it's 0, so it would be 1. So this means that our expected value, it's equal to 1 over p, because n equals 1, so everything else is 1. So instead of having x over p, we have 1 over p. And our variance, on the same token, is 1 minus p over p squared. So again, same thing. For the uniform distribution, our PDF is 1 over b minus a, and our CDF, when we are trying to calculate given values, we've seen that it's x minus a, b minus a. Our expected value for an uniform distribution is essentially the average. And if you think about, remember that we are looking at a rectangle, so essentially you're looking at the mean value. And the variability, so the Vx, it's b minus a 2 squared over 12. If you want to have this in a PDF form, drop me an email and I'll send you the summary of this. It's important for you to know the main key properties, because when you are solving problems, it's like having stuff in your toolbox. It doesn't equate to anything trying to figure out everything every time from the beginning when you already know some things in advance. And if you have all the typical distributions that you're going to see in statistics exams, and if you know key properties, for instance, like the Poisson, where the expected value is the same as the V of x, and a couple of other ones, let's say like the binomial when you are relating it to the Bernoulli one, or if you're looking at the negative binomial and comparing it to the geometric one, you start understanding its properties and you can use it to simplify expressions. I hope this helps.